Next, we'll take a look at graphing a hyperbola whose center is not at the origin. So let's see if we can graph this one. So first, we'll take a look at where the center is. So we look at the equation and we say x minus what? 2. Y minus what? Negative 1. So we know the center of this hyperbola is at the point 2, negative 1. So let's go ahead and put in an axis system and locate the center. Next, we're going to find the vertices of the hyperbola. So we look at the first term, and in the x direction, we'll move the square root of 4, or 2 spaces. So from the center in the x direction, we'll move 2, 2, and now we know where our vertices are, and we know the orientation of our hyperbola is going to look like this. Next, we need to know how wide or narrow the hyperbola is, and so we need to look at the slopes of the asymptotes. The slopes of the asymptotes are plus or minus b over a, b always being the square root of the number under y, and a always being the square root of the number under x. So the slopes of the asymptotes would be plus or minus 5 halves. So from the center, we go up 5 and over 2, 5 and over 2, and sometimes people feel more comfortable drawing a box and using the box, the diagonals of the box to make the asymptote. So you don't have to draw the box. I'm just going to draw it in because your book uses a box. But you can actually just use 2 points to find the slopes of the asymptotes as well. And so one asymptote will look like this, only straight, and the other asymptote will look like this. So we can see that we're getting a very wide hyperbola. Here we go. Okay. So why don't you see if you can find the coordinates of the foci? Just as a reminder, the distance to the foci is the square root of, and let's look at our notes from before, and our example from the last time, the distance to the foci is the square root of the sum of the denominators. So 25 plus 4, the square root. All right, why don't you see if you can then find the coordinates of the foci? All right, let's give that a check. So the distance to the foci is the square root of 29. The square root of 29 is somewhere between 4 and 5. So from the center, 1, 2, 3, 4, and a little bit more. 1, 2, 3, 4, and a little bit more. Okay, so from the center, now remember the center has the coordinates 2, negative 1. So this focus right here has a different x coordinate. We're going to start at 2, and then we added on the square root of 29. So the x coordinate is 2 plus the square root of 29, but it has the same y coordinate as the center, which is negative 1. This focus, we started at 2, and then we went to the left square root of 29. That's 2 minus square root of 29, and again, it has the same y coordinate. Let's practice graphing one that's not in standard form. Remember, this is going to be an easy first example. What is standard form always equal to? Standard form is always equal to 1. So we'll divide all the terms by 36. So now we have y squared over 9, because 4 over 36 is the same as 9, minus x squared over 4, because 9 over 36 is the same as 1/4, is equal to 1. So we can see that the center is at the origin. Go ahead and see if you can sketch what this hyperbola looks like. So find the coordinates of the vertices. And then see if you can graph it for yourself. Okay, let's go ahead and check what you did. So we know the center is at the origin. So we know the center is at 0, 0. To find the coordinates of the vertices, we're going to look at our first term, And in the y direction, we're going to move 3 units. So from my center, in the y direction, we'll move 3 units, 3 units. So the coordinates of the vertices are 0, 3, and 0, -3. Next, to finish graphing the hyperbola, we need the slopes of the asymptotes. So the slopes of the asymptotes why don't I pause there? Go ahead and fill in the slopes of the asymptotes. Okay, the slopes of the asymptotes are plus or minus b over a. B, always the square root of the number under y. A, always the square root of the number under x. So the slopes of the asymptotes are plus or minus 3/2. So from the center, I go up 3 and over 2, up 3 and over 2. And now you could just draw in the asymptotes, or you could make a box, up 3 over 2, to help you draw in the asymptotes. But in any event, you have 2 lines, one with a slope of positive 3/2, the other with a slope of negative 3/2. And so now we can go ahead and graph the parabola. So starting at, the hyperbola. So starting at the vertex, we get very close to the asymptotes, and there we go. All right. Let's take a look at what's required if we have a hyperbola which is not in standard form. All right. Now, the last one we did wasn't in standard form, but it was very easy to put it in standard form simply by dividing by 36. But you can see that this one has a little more work to it. So we're going to approach this the same way we did ellipses. We're going to group the terms together so that all the x terms are together, all the y terms are together, and the constant is on the other side. Now I notice that I have a typo here. There should be a negative because you can't have 2 equal signs in the equation. So here we go. So let's go ahead and regroup this. So I have 9x squared minus 36x minus 4y squared minus 40y. So we've grouped the terms together, and now we're going to move the constant by adding 388 to both sides. And this is how we're starting. Okay, we're going to factor out the lead coefficient. Now be careful here. We're going to factor out a -4, which means the second term is positive 10, because a -4 times a positive 10 would give us our -40. So be careful with your signs. Okay, and now we're going to go ahead and complete the square. So we take half of 4, which is 2, and 2 squared is 4, so we're going to add 4 to this side, but on the other side, we're going to add 36. Here, we're going to add half of 10 is 5. 5 squared is 25. So here we're going to add 25, but on the other side, we're going to add -4 times 25, -100. Okay, so let's see what we have so far. We have 9 times x minus 2 squared minus 4 times y plus 5 squared is equal to, and let's go ahead and see what we have on this other side. We have 288 plus 36. That gives us 324. We're almost ready. We're going to divide every term by 324 because we need this equal to 1. All right, so let's hope that these fractions reduce. Yay. All right, so this first one is x minus 2 squared over 36. Let's try to reduce this next one. Great. This is going to be y plus 5 squared over 81 is equal to 1. And now that it's in standard form, we can go ahead and graph the hyperbola. So why don't I get some room here so that we have some room to work on this. All right. So go ahead and see if you can find the center. Let me get you started. The center is going to be at 2, -5. Go ahead and find the slopes of the asymptotes. Okay, plus or minus b over a, and then see if you can sketch the hyperbola. All right, so let's go ahead and check. The slopes of the asymptotes, remember b is always the square root of the number under the y term, so it's plus or minus 9 over 6. So our center, we might not have enough room to graph this one on this little sheet of graph paper. We'll see. All right, so the center is going to be at 2, -5. The slopes of the asymptotes are positive 9, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. I'm going to reduce that so that I can graph it more easily. So this is 3 over 2, so up 3 over 2. Okay, so here's one asymptote, and up 3 over 2, here's the other asymptote. To find the vertices, in the x direction, we're going to move 6. So in the x direction, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And now we can sketch this very wide hyperbola.